Awesome. Hey everyone, my name is Erfan, and today I'll be talking about climate change, AI, and a little bit about entrepreneurship. About me, I am currently a junior studying computer science at Stanford University, and then I have been doing a lot of research for using AI for social good, like climate change and healthcare. And I was recently working also at a startup building the largest AI chip in the world, Cerebus Systems. So I'm like very passionate about just using tech for uh, things that will make a big impact. And I'll just start. Uh, so you probably none of you disagree that the pandemic that has been happening has changed our life in many ways because it is very immediate and the impact of it can be felt in a very short period of time. However, beyond the current pandemic, arguably the greatest challenge that we are facing that is staring at us is something that is less pressing and hidden, but much more massive: climate change. And climate change is almost, to me, it's like a predator. You know it's guilty, but you can like show particularly like pinpoint exactly like this is the criminal activities of climate change. But scientists talk about a lot how our climate is being affected from pole to pole in so many ways. Like global temperature rose for 1 Celsius in 100 past 20 years. Sea levels are rising, glaciers are shrinking, carbon dioxide in the atmosphere is increasing, snow is melting earlier compared to long-term averages. And I think from the predictions, experts said that the world has less than 10 years to halve the greenhouse gas emissions uh, before it goes up. The temperature goes up by 1.5 Celsius degrees, an amount that we really can't imagine what the world would look like in future if it happens. So responding to these challenges, there are usually two ways to go about it. One is to reducing emissions and stabilizing the levels of heat trapping greenhouse gases in the atmosphere, called mitigation. Second one is adapting to the climate change that is already in the pipeline, called adaptation. To just explain this adaptation versus mitigation more, mitigation is a piece of the puzzle that's easier to explain, but difficult to accomplish. Like we must transition from powering our world with fossil fuel to using cleaner, renewable energy. And we need to stop deforestation, restore our natural habitats until we reach net zero carbon emission, meaning that the release of carbon gases should be balanced by how much it's being stored in the ground, like tree roots. And the sooner we act on this, the better off we will be in the future. For the adaptation part, let's say if you grew up in Brazil and you suddenly moved to Canada, you wouldn't survive long if you didn't make adjustments to your lifestyle. Like you need warmer clothes and you need to learn how to drive an icy situation. Uh, in other words, you have to adapt to a new climate. In a warming world, you don't have to move somewhere to experience the change. The new climate is coming to you. It's going to affect how we're going to grow our food, how much water we have, how we build our houses. Um, but that's why we're here today. That's what brings us to know more about our role in a constantly changing environment and see how we can play play our role in a good way to stopping this beast from devouring us. For me, the answer is AI. just building scalable models that's complementary to human intelligence. I think the first piece that I started with was this paper called Tackling Climate Change with Machine Learning, conducted by the most prominent researchers in the AI field, about 22 of them. They mentioned 13 areas where ML could be developed for energy consumption or CO2 removal or education. The paper is a bit long, like 100 pages, but then kind of you can summarize it in this table. The table was big, that's why I like rotated it to fit here. So on the x-axis, we see different sectors like electricity systems, transportation, buildings and cities and industries, farms and forests that are sectors that climate change is having a substantial effect on it. On the y-axis, we have different AI techniques for addressing the challenges in these sectors. Let's say we have like computer vision, interpretable models, NLP, reinforcement learning, transfer learning, unsupervised learning. There are just so many types of learning that they have their own techniques and characteristics that could use. For example, like let's say for buildings and cities, you can use computer vision to just better monitor cities and urban planning and get insights from satellite imagery that you would never you couldn't get before. When you review all these methods, I mean, probably if you don't have the time to read the whole paper, you can go to the sections that you want, and it will just like give you a small intro of like what are the challenges in that sector and what could be done. But you can summarize the solutions in 5 categories. I'll be going through those 5 categories and giving examples on how AI could be useful. The first one is filtering data into actionable items. AI could help with that. And actionable insights are like meaningful findings that result from analyzing data, and they make it clear what actions need to be taken or how one should think about an issue. Organizations use actionable items to make data-informed decisions, and that's what like AI is good at, just consuming a lot of data and then spitting out insights from it. This is a project that I was working on called MethaneSat. It's a satellite that's being launched in 2 years. Like a couple of universities and Environmental Defense Fund in the US are participating in this project to launch the satellites to track methane emission and reduce it by 45%, hopefully. I mean, the largest source of methane is cow farts, but after that, the leakages from oil and gas facilities are enormous. So what I was working on was to get satellite imagery and detect where are the locations of these oil and gas facilities, and then feed it later. Hopefully, it will be used for the satellite to go and then use sensors to like detect the methane in those like spots that we have fed into the satellite. And if there are issues, they will report it to either the government or the corresponding companies. And this will equate to a reduction of like 0.5 Celsius degrees, hopefully, if this project gets out. The second area is optimizing complicated systems. Deep learning specialists like to estimate uncertainty in systems. And for each potential action, there are billions of parameters and actions that could be taken. An AI engine can calculate the confidence, what is a good action. And when it has low confidence score for an action, it could be eliminated. So because the sheer number of these actions, it's really hard to know what is the best, how to optimize for the best, and execute on all of them simultaneously. And that's why we use AI to keep track of these millions of parameters in its memory to take action upon. Good example of such work is what Google did in their data centers when they acquired DeepMind. They started running this model in their cloud centers to reduce energy consumption through cooling, and they were able to reduce energy use for 40%, which is a substantial amount. And nowadays it's becoming more prevalent in data centers. Like 24 millions of kilowatt hours have been saved in 40 locations, which is equal to $3.5 billion. And it's a lot of money being saved. The third category that AI can be useful is accelerating scientific discovery. Researchers are fundamentally changing the foundation of scientific discovery process using machine learning and AI. The example that I've mostly seen has been in like drug discovery, because traditional drug discovery pipeline is costly and time intensive. For a new drug to reach a market, it takes 10 years and almost $2.6 billion. The vast majority of these drugs and research fail at testing stage, and it means that valuable time and money is just being thrown out of the window. There's this startup, Evotech, that's doing drug discovery, and they are combining deep learning with generative models and optimization methods to generate new medical artifacts with desired properties. And they've been able to reduce the discovery process from 4 to 5 years to 8 months. And that's a lot of time being saved. The other category, fourth one, is making AI is very helpful in making climate simulations much quicker. Modeling immensely complex natural phenomena, such as how particles interact with each other, can take many hours, even on the fastest supercomputers. And emulators like algorithms that can quickly approximate these detailed simulations are a shortcut for this. One of the Stanford researchers, Melody Guan, developed this deep emulator network search that is able to provide 10 simulation for almost 10 categories like astronomy, physics, geology, and climate science. And the emulator can run 100,000 times to 1 billion times faster than existing simulators in those fields. So AI is pretty good at making that also faster because it uses approximation, and it's pretty accurate. I think the last one is AI can help with improving predictions. Prediction is generating data that you don't have, often by translating large amounts of data into small manageable amounts. Like you can divide an image into parts and detect whether there is a face in that image or not. And that prediction is a classic example of how an AI can just extract information from small amounts of data. And the more these machines do predictions, the cost will fall down more, and we will get much better at making better decisions based on these predictions. I remember the example that came to my mind for this was Climate AI. It was a startup that I was interviewing for last year, and I was hoping to join, but I couldn't join them. They were like a cloud-based software company that predict physical risk of climate change on real asset through weather forecasting. The company uses open source satellite imagery and machine learning to make weather forecasts from 2 weeks to up to 50 years. And once you have that ability, you can ask very deep questions of like, okay, how will these changes affect my business and how it will relate to me? Can't remember exactly my conversation with the founder, but like after a year and a half or 2 years when the model started working, they were like fascinated by how accurate it was. I mean, I know the goal is to make use of AI as much as possible, but to really help fight climate change, users need to be skilled of the pitfalls of a technology as well. It's like a knife. You can use a knife for cutting fruits, cooking food, but at the same time, it could be dangerous and cut yourself. So there are pitfalls with AI. And for example, like big tech companies provide AI solutions to oil and gas firms to optimize exploration and production of fossil fuels. And that's something concerning. Beside that, the AI itself can also be damaging. Like, look at large language models like GPT-3. They're getting bigger and bigger every day. Like GPT-3 was 175 billion parameters. And if you just want to use one GPU to run this, it takes 355 years and almost cost $4.6 million to just train this model. So, and it takes so much energy to train one of these large language models. And there was, in fact, there was a researcher in Google, I think she was the head of ethical AI in Google, Timnit, that she wrote a paper on this, that it was the time that Google released Switch C, which was even bigger than GPT-3. And they were analyzing the footprint and the impact of these models, the carbon footprint. And she got fired after that because it seems like the big tech companies don't like to talk about this side effect of the models that are running on so much power. And then, of course, AI can, it's a big field right now, AI explainability, that there is a lot of bias because the data that we are providing to these models are biased. And then we're letting them to take power over our decisions, like these intelligence machines, but we really don't know how they're thinking. It's a black box. Now there are methods coming up on seeing what's happening inside this black box. What is it seeing? How does it interpreting the data? And then adjusting mostly on the data pipeline to fix these biases. But it's really difficult to capture these loopholes in the training process. So that's something to be aware of. And finally, I think that we just need more than AI to solve such a big problem as climate change. Like, you can't just lock yourself in a room and then expect that everything will be fixed through just coding. No, you have to get out. You have to see the world. You have to interact with people, see the real problems, and get domain expertise. See, like, after identifying the problem, what are the solutions that we could provide? Maybe AI is not the best solution. So I like that mindset of approaching and need finding first before finding solutions for a non-existing need. So get out there and see what's happening there. That's why, for me, this getting out there has been through entrepreneurship, and I follow climate tech or clean tech closely. It's probably one of the fastest growing industries, like in tech, like climate tech. There are just so many startups being started. All of them are trying to work toward just getting a small piece of this large issue and see how they can help with fixing it. When you look at the VC side of it, like, some people might say, hey, like, it's social good, there's not money, nobody's willing to pay money for social good. But I think this is changing. If you look at the VC trends, like, there are around 2,700 unique investors from venture capitals and angel investors and philanthropies and government funds who are participating in funding like climate tech startups. There are like from 2013 to 2019, there were 1,200 climate tech startups. So it is growing. Like in 2013, climate tech attracted $418 million in venture capital. And by 2018, nearly 50 times as much as capital was deployed. Only during last year, during the pandemic, the venture industry as a whole deployed like around $264 billion in climate tech. And as you can see in the chart, like mobility and transport is taking the biggest chunk of it. And after that, food and agriculture is the main area of interest for these investors. And then the smallest one is climate, earth, and data generation, and this VC interest in investing in tech startups. So this is what they had. Feel free to ask any questions you have about this entrepreneurship in climate tech or AI in general, and I'll be happy to answer them.
Was that a question? I couldn't tell. All right. Well,
anybody has a question?
Yeah, feel free to just speak up or put in the chat, and then, or even like how to implement AI software into your whatever you're creating.
I have a question. How would I? Is my mic clicking?
Mm-hmm.
Okay. Like how would I put, I guess, AI software into like I'll take AI like data and like put it into an app.
Into an app. That's a really good question, and also a challenging one, because depending on the task that you're doing, a model could be big or small. So let's say you're running an image detection algorithm. You see a cat in the screen, and then you want to like detect the cat when you're pointing the camera at it. And depending on the model you use, it might not fit on the phone, because phones have like limited capacity. And I know that there are some frameworks being developed for this, like TensorFlow.js. That is, the main use of it is to use JavaScript. Like TensorFlow is a deep learning, like it's a AI deep learning platform that you can use like image recognition, or like text, what's it called, speech recognition, and then deploy it to your phone through like the JavaScript. And I haven't done it personally. So that's one way, but I think it is very technical. Other ways is to like use existing APIs that you can just like make API calls. Let's say I don't know, I don't have an example on top of my mind, but then like let's say Siri, okay? When you're using the Siri on your phone, you say, "Hey Siri," and then you use, okay, "Hey Siri" is detected as stuck on my computer. When you say the sentence, it will go to the cloud, and then it will give you a response. And I think that there are like APIs, if you Google it, there should be like speech detection or like image recognition APIs that you can just like, let's say if they're in JavaScript or React Native, it should be like the packages should be integratable in your app, and you could just send the data and then get the results from it.
Another question. When you're coding like AI, what like, I guess, language you use?
Yeah. So I mostly use Python. And then the good thing about AI is so it's the code, like just coding AI from scratch is really difficult. But right now we have existing libraries that makes it much easier. Let's say like PyTorch Lightning. When you like it abstracts away a lot of the complexity of what's happening under the hood, and you just like type in, "Hey, like this is my model, this is the data." You like try to match the model with the data, and then after that you just do, let's say, model.train, and it should do the work. But then you can go like more advanced, like use TensorFlow or PyTorch itself, but those are a lot more difficult. Like no code AI is becoming like more prevalent these days. PyTorch Lightning is something that we as researchers mostly use in universities because it's just easier, but also gives us flexibility to implement code. However, I know that there is like some what's it called, libraries like Gladio. I can Google it and then give you this full name itself. That it's even like much more simpler. It's just like writing a few lines of code that will download a model from the cloud for you, and then will tell you how to pre-process your data and then feed into it. But it's mostly all of this stuff are in Python. Let me just Google that.
And then another question was, what is a generalized AI? Are there any examples of generalized AI models?
Generalized AI. I'm actually, to be honest, not very familiar with the terminology of what is a generalized AI.
Okay, I have a question. So, we were talking. I like heard about like AI, and it's like about getting data and like analyzing it and making towards solutions. So like, what's the difference between using AI and versus using like a data analyst model? So, what's the difference between like data science and using machine learning?
Machine learning. I think for data analysis, by the way, I just sent one of the libraries, one of the packages that makes it much easier to use what's it called, just these mostly NLP models with a few lines of code. But then going back to your question, John, I think the thing about AI is like when you cannot keep track of a lot of parameters, you can use AI. Let's say you have like 100 variables, all like covariants and are dependent on each other. And then finding correlations between these parameters is really not possible through Excel sheets and then R language or like MATLAB, because those you have to like specifically look out for a specific pattern in one variable and then see how it correlates with the rest of the parameters. And it's hard to, what's it called, hard code all of that and then capture all the nuances of the relationships of the parameters together. But then in AI, let's say you use like neural networks. Neural networks are something that they try to replicate how brain works. Basically, I don't want to get very like technical, like they added nonlinearity on how they looked at data. And then by that means that they try to simulate like how our brain to some extent works in looking at the data. And then it absorbs all those information in what's called weights in itself, that you don't know what it's learning, but then it can detect the patterns. It can detect how these things are affecting each other, like a lot of parameters. Like let's say an image is like an image 100, like a 23 megapixels image, like the size of your camera's phone. That's like millions of pixels. And if you just want to detect, let's say, an image of a cat in these millions of pixels, just doing data analysis itself is really difficult. But then when you use like these neural networks, it can learn all of this stuff automatically. It doesn't know how it's learning, but it can detect the patterns.
So that methane sat that you're talking about was really interesting. Can you elaborate a little on that? Like, what exactly do you work on that? And do you think I will actually reduce the temperature? It'll actually reduce the temperature by 0.5 degrees.
Degrees, yeah. So my task was, this is a collaboration between Columbia, Harvard, and Stanford and EDF. We were mostly like doing the data set generation for the methane sat. Harvard was mostly in charge of the methane analysis through their sensors. So let's say like Earth is like really big, and then you only have one satellite that needs to go around and then look at all the places that there can be methane leakage. So what we do is, so one satellite cannot do that. There are existing satellites that are taking pictures of the Earth every day. Like we have something like planet.com that you get 24 hours daily picture of the whole Earth. And there are other like satellites, let's say like the Google Maps, that's like more like 2 to 3 years updated interval, but with much higher quality. We'd look at, our task was to get these images and then look for an oil well, an oil facility. And then, because there is not a good data set of oil and gas facilities globally. So we would use this computer vision to run through all the images throughout the Earth. I mean, or at least the places that we were suspecting there are going to be like oil fields, and then just record a geographical coordinate of those. And then later we would just provide these geographical coordinate to MethaneSat. MethaneSat itself doesn't have a camera. It just has sensors. But the camera is like the satellites before that has taken pictures. And then the 0.5 Celsius degrees. So methane is 30 times more potent than carbon dioxide, even though the emission rate is much lower, but the impact of it is much higher. There are already existing satellites like the GHG sat that is by the European space station. They're also like tracking methane around the globe, and they have not been able to achieve a substantial result, even though they're still like doing work, but it's not been fully successful. And I think that the goal is to get more of these satellites in the world in the orbit, and then have them to do more frequent scans, and also just be harsher on the company. Like I know a lot of oil companies have like disputes about this project because this is like literally like a I and them and C. They will just that it will detect like so many flaws in the designs of the thing they're doing. So there is some lobbying there probably there, but it's about trying and being hopeful.
All right, I got another question.
Mm-hmm.
So, I heard you made a point that you can't just use like AI and rely on that in order to solve like the environmental problems. Like, is there any like, can you like understand or like be able to use AI to understand kind of the ethical and like sociological problems, not just purely using it for like just focus specifically on technology?
That's a really good observation, and I think there has been like great work in that field. Like one of the advisors that I was working on for a project before MethaneSat, I was working on detecting boundaries of agricultural fields through satellite imagery, and then kind of segmenting those agricultural fields out from each other, and then just making a global data set of that. I couldn't finish the project, but one of the projects they were working on previously, which got published in Nature, was detecting poverty through satellite image, through night light. Basically, the idea was to take images from above, and then in areas, depending on how much light intensity is, like if it's a very wealthy city, there's going to be a lot of light. If it's a poor area, probably there's not much light pollution, there's not much like light intensity. And they were able to map the whole continent of Africa on like how poor like each area is, and they're like able to make a very granular map of the whole continent of their poverty. And that helps a lot with politicians making decisions later, because data is power, and if you don't know much, you can't also do much. And through these like bird eye view projects, they are able to overcome the cost of sending manual labor to do surveying, which are not very accurate. and overcome that problem, and then provide good data to politicians and decision makers and philanthropists. So there are real world like impacts through this kind of stuff.
Thank you.
I can send the paper as well. It's a really cool paper. This is like a news on it. It's not a research paper itself. That was a really good question. Yeah, thank you.
Does anyone else have any questions or any things that they found was interesting? Cool. Well, if anybody does have any other questions, since we are running out of time in this session, do let us know and we can contact Erfan, or I think his email
as well.
Yeah. His email is also on the hackathon guide, I believe. So if you do go there under mentors, you can also just email him. And yeah, we don't have a session for a little bit, and we have our next session at 5 p.m. EST in 2 hours. We'll just talk about sustainability and environmentalism. And yeah, cool. So here is that link. So it'll be kind of building on things that Erfan said about poverty, environmentalism. So that'd be really cool to attend. So do come there. Yeah, I'm going to stop the recording. All right.